Question 1, cool one. Press pause, I write this question down. Press play when you are ready. So this question is all about converting a recurring number into a fraction. Take note that we have a recurring sign, a dot and a dot on the first and last digit of this number. This simply means 0.254, 0.254. It's the same as saying basically dot, dot, dot. So don't worry if you don't see all three dots on every digit. The first and the last digit, it will suffice to make it mean recurring. Let's first of all write 1x or x. X equals 0.254, and we'll basically look at how many times this digit is recurring until it repeats itself. So it's 3 times, it's 3 digits on a recurring basis. So basically let's look at this as 1000x. 1000x we're going to write over here because we have 3 digits recurring. So this will be 254.254, and we'll put the dots over here. Let's now take away from each other these two numbers. So we're going to be doing 1000x, take away 1x. This is going to be 999x, and this is going to be 254, a nice whole number over there. Take note how everything after the decimal over here and the decimal over here are the same. 254 recurring, and that's what you want already to cancel them out. If it's not, then obviously look back, it may have gone wrong somewhere. 999x equals 254, very simple. X equals 254 over 999. I assume we can't break that down any further, only because we have an even and an odd number over here. So that's your final answer for this question. Question 2a, core 2. So let's look at this exam question over here and let's find out angle x on this. This is in terms of x, so we want to see if you can write this in terms of x rather than just a number. Press pause and press play when you're ready. Now AB are points on the circumference, A and B, center 0, and we have BC, which is a tangent over here. AOC is a straight line over there as well. Angle ABO is x degrees. Find angle ACB in terms of x. So ACB. It wants you to find this one outside in terms of x. So there are a couple of ways of doing this. Let's look at any way you want to. But it's worth stating that this is not to scale first of all. And you probably will notice this in a second. Okay, so we'll just write this just so you understand that we can use either of these methods over here. Right, method 1. Now let's look at this. We have two radii over here because we have AO and OB. This is a key feature. All right, what does this tell us about this? It tells us we can use this isosceles theorem to figure out the other angle over here, which is, let's say, AOAB. All right, and this will be x as well. Therefore, this is a triangle AOB. This could be obviously 180 take away 2x. So we could write this over here as 180 take away 2x. All right, and therefore we could figure out this angle over here. We could say, all right, we have a straight line. So therefore, what is this angle over here? Because we're trying to find out all the angles in this triangle BOC. So this one would be, let's work it over here. All right, so we have now 180 straight line. This is because take away 180 take away 2x. All right, because it's a straight line. We'll put a little thing over here. All right, this is how you identify this. This is where your algebra's got to come in quite nicely, actually. So we've got 180 take away 180 plus 2x. The reason why, this is imaginary minus 1. Minus 1 times 180 is minus 180 here, but minus 1 times minus 2x is plus 2x. That's a major misconception with students sometimes, okay? This will simply lead to 2x, so this therefore is 2x over here. This over here now, this is a radius, this green bit, and this is a tangent BC. Therefore, we could say that this blue bit over here is 90 degrees. Hence, it's not to scale. That's why we mentioned that at the beginning, all right? So don't just look at this at the beginning and think that's not on the right angle. Radius means tangent. It is 90 degrees. So this is 90 degrees. We have this. We have basically, this would simply be 180 take away 90 plus 2x, which would be the same as 180 take away 90, which is 90, and we're left with minus 1 times 2x over here. This would be minus 2x. So that would be a final answer, 90 minus 2x. That's one way of doing it. Let's show you method 2 of how you could do this question as well. Now method 2, let's go through this second alternative. You could use this. It's probably slightly easier, and we'll show you why this is. Now let's look at the bigger picture. Bigger picture means the bigger triangle. So we have A, B, C. Okay, so the bigger triangle A, B, C. Let's see if we can figure out a basic concept. All three add up to 180 degrees from a triangle. A already over here, or let's say OAB, that's going to be x degrees. All right, because obviously this is an isosceles triangle. B over here, okay, ABC, this would be x plus 90. Because obviously when radius meets tangent, we figured out that this angle is 90 degrees. And then this we're left with C. We'll call it C if you want to, or let's call it ACB to make it a bit more technical. This should equal 180 degrees. X plus x, let's figure out this left hand side. X plus x is 2x plus 90 plus ACB equal to 180 degrees. Let's carry on. We'll do this in one step. ACB has to equal therefore 180 take away 2x, take away 90, which therefore is 90, take away 2x. That should be snap with the method 1 we just worked out. So go through both of these alternatives, make sure it works for you, and these are two different ways of interpreting question 2a. Question 2b, core 2. So again, we're looking into making an angle in terms of x, testing you thoroughly on this. Write these questions down, part A, B, and press play when you're ready. Now ABC are points on the circumference center O. A, B, C. AB is a chord. We can see this over here. AB, going right across. Angle AOB is 2x. Okay, and DBE is a tangent over here. Find angle OBA. So angle OBA, let's color code this. Let's call it green. OBA, this bit over here, that's what you want to find out. Right, let's go through this. So what are our key features again? So key features, we're looking again at OA and OB being two radii. Okay, could be isosceles over here. What else could we see? We can't do a cyclic quad. Only 3 points on this circumference. Could be the alternate segment theorem. Well, we're looking at two different triangles. You know, if you look at this, ACB and AOB being two different triangles, maybe we could apply a bit of that. Let's see how we go. So already we've looked at different circle theorems. And one more, in fact. Look, if the center is O, radius meets tangent, 90 degrees. That could be one as well. Right, so there are about 3 or 4 different theorems over there. Right, now let's answer the question. OBA. Let's look and see what can fit into our model with those key theorems. So this bit over here. So we have an isosceles triangle. OA and OB are two radii. Hence, let's see what this could be and this could be in terms of all three adding up to 180 in this triangle OAB. So one of these over here would be 180 take away 2x, and the whole thing would be divided by 2 because obviously we've got 2 x's over there. So that would literally give us one of these. It would give us this one or this one over here. All right, so this would be literally, if you divide this by 2, it's like say 180 over 2, take away 2x over 2. Same concept, 90 minus x. That would be one of these over here. It could be this one over here, or it could be this one over here. The choice is yours. But we'll write this as 90 minus x and 90 minus x. That's part A for you. Right down to the isosceles triangle theorem. Angle ACB. Now ACB, let's color coordinate this again. ACB is this one, ACB. You want to find out this one over here. So there are a couple of ways of doing this. Let's look at the first one over here, method 1. So method 1, it's saying, now this one, OCB, you should look at this triangle over here, ACB, this triangle, and this is the, let's say, top right of this, and the bottom left would be this one over here. All right, so this looks like the alternate segment theorem to us. That's what we measured as a key feature. This bit would be the same as this over here. You see, top right, bottom left. So all we need to find out is this brown bit on the left. Now this is a radius. We said radius meets tangent. This is 90 degrees over here, and we found out what this angle was in part A. It was 90 minus x. So if we look at this, we have 90 plus, that's 90 degrees from here, plus our answer from part A, 90 minus x. Okay, this has to equal ACB. Okay, from alternate segment theorem, bottom left, top right. Let's just work this out a bit more. 90 plus 90 is 180. That's imaginary 1 times that. And obviously, minus x, 80 minus x will be your answer. So a bit more difficult in terms of spotting that, but not too bad. A second alternative could be this over here. We can use this notion of the double angle theorem. Now this is what we're going to want to find out, ACB. Hence we could find out this over here. This would be double the angle of ACB, okay? This angle over here. We can call it, well, this one over here. Yep, so this one, if it's double, first of all, let's name it as this. This whole circle will be 360. So therefore, this would be 360, take away 2x. So 360, take away 2x would be this. This bit, ACB, would always be half the angle from the double angle theorem. Hence, it'll be half of 360, take away 2x. So we half that. Let's see what we get. This is actually quite a simple way, in fact, but it's harder to see. Divide this by 2. Method 2, by the way. This will definitely give you 180 take away x, which is the same snap. So either way, whatever you find easiest, you could do the alternate segment theorem over here, or the double angle theorem on the right over there. So press pause, write parts A, B, and C down, and press play when you are ready. So in this question, it's slightly different from the ones before because we have a minus powers. How do we deal with this? Now, let's remember in maths that any number can be represented with 1 underneath this. Not that that's just this topic, but any number can have imaginary 1 underneath that. So this will help us because this minus power allows us to flip this. So we're going to be putting 1 over 4. And when we do this, we can now get rid of the minus power on top, and we can square root both the top and the bottom separately. So 1 over half over 4 to the power of half. So square root of 1 is simply 1, square root of 4 is simply 2. So half would be the answer for this. So part B. Part B is very similar to this. It says 27 this time to the power of minus 2 over 3. So in this case, again, we look at the minus power and we think, how can we get rid of that? We're going to write 27 over 1, and we're going to flip this. So we flip this as 1 over 27, and this gets rid of the minus power. We then look at the 3 over here, the bottom number first, and we cube root both of these. So it's like 1 over 27 to the power of a third. Same thing. So this will bring us 1 over 3. Now we can square this because we have a 2 on top over here. So 1 squared is simply going to be 1, and 3 squared is simply going to be 9. So 1 over 9 is the final answer. So just again review that. There are quite a lot of steps. It doesn't matter if you don't put every single step over here. As long as you understand the gist of this, that's all that matters. So last one, 125 to the power of minus 2 over 3. So again, let's write 125 over 1. And let's flip this. So we're going to have now 1 over 125 and the whole thing to the power of 2 over 3 because the minus goes. We look at the bottom number again, which is 3, which means cube root. So we'll do the cube root of both of these individually. So the cube root of 1 is simply 1. The cube root of 125 is 5. Now we'll look at these and we'll look at the top number, which is a 2, the squared, and we'll square both of these respectively. So 1 squared is 1 and 5 squared is 25. So again, that is part C to this question over here. So these are core questions. Just make sure, again, you review this nicely. Press pause, write this equation down, and press play when you are ready. So again, we're going to be dealing with a quadratic formula to solve this quadratic equation over here. And the reason why is you should obviously use a quad box. If you can't do it, your last resort is your quadratic formula. So we have solving x squared minus 4x minus 6 equals 0. Write your answer in the form a plus root b and a minus root b, where a and b are integers. So this is definitely a non-calculator. We're going to be using the same principles for quadratic formula. So let's define a, b, and c step 1. So obviously we write this really quickly over here. Ax squared plus bx plus c. Let's define a, b, and c. A, b, c. Okay, let's do it. Step 1. A equals 1, b equals minus 4, c equals minus 6. Okay, that's pretty self-explanatory. Step 2, let's plug them into our formula, which we should memorize. So step 2, let's memorize this formula. So minus b, x equals minus b plus minus, you got it, b squared minus 4ac. The whole thing is going to be over 2a. So let's plug it in. Let's do this bit over here first. Okay, so we're going to plug this into the calculator. Get your fraction button ready over here. Look for this button. And let's go for it. So we've got this. We've got now minus 4. This is the trick that most students aren't aware of. Minus 4. Look at how we put the bracket there. That will lead to a positive result. We've got plus and the minus over here. We've got the square root. Now look at this one again. We have a minus 4 squared. You have to put brackets when you deal with the minuses, especially when you square it. So please understand that. If you don't put the brackets, the calculator will just do minus 4 squared and give you minus 16. So do a bracket over here, please. Minus again, 4 times a times c. A is 1, c is minus 6. We'll close the brackets over here. The whole thing will be over 2a. So 2a will be 2 times 1, which is simply going to be 2. Okay, let's go a bit further and let's simplify the top bit. So that's 4 plus, this will be minus 4 squared, 16, minus, open brackets, 4 times 1 times minus 6 is minus 24. The whole thing will be over, again, simply 2. Next step, it'll be 4 plus, so 16 minus 24 is root 40, because obviously 2 minuses make a plus. The whole thing will be over 2. Now this is the same thing as saying 4 plus, if you look at this, root 40. How can we get two numbers to multiply to get root 40? One's a square number and one's a non-square number. That's the key, a square number, a non-square number. We have root 4 times root 10 over here. And the whole thing can be put over 2 again. This could lead us to, obviously, 4 plus 2 root 10 all over 2 again, which is the same as saying 4 over 2 plus 2 root 10 over 2, which is 2 plus root 10 if we have enough space over there. And that's how you work out that on a non-calculator. You keep going with the surds. The trick was root 40 was root 4 times root 10. So step 3, let's push it up here. Step 3 is simply to find out the I wouldn't say the negative value of that. It doesn't mean if it's a negative value here, that it's a negative value in the answer. The negative version within the quadratic formula would be this. So it would be 4 minus root 40 over 2. Now if we do the same thing again and again, obviously we're going to get the same answer over here. It'll simply just be 2 minus root 10. So that's your second solution over here. So again, look through these. Steps 1, 2, and 3. It comes up all the time in the quadratic formula. So step 1 again was to define a, b, and c. Step 2, create your quadratic formula and plug in your values. Step 3, find the other value with the minus at the back. Press pause, write this fraction down, and press play when you are ready. So remember, the key trick is to identify what type of factorizing problem we have over here. So if you look at this numerator 5x plus 10, this is an example of simple factorizing, okay? Let's look at another expression, x cubed minus 4x. This is a basic dots. 3x minus 1, can't do much with that. That's not really anything we can actually factorize. But 6x squared minus 14x plus 4. This is an example of advanced quadratics, advanced quad box. And take note of the divide sign because we could flip a few things in this question. So let's deal with each one. So the trick is to just identify it and factorize each one of these expressions individually. 5x plus 10. Let's factorize this. So 5 outside, x plus 2. Now, this is hidden dots over here. We'll take x outside because x is in both. Treat it like simple factorizing. What goes over here? X squared minus 4. Okay. Take note, we can do something with this x squared minus 4 a bit later on. Divide. Let's flip this around straight away. Okay. So what we see over here goes over here. We'll make this a times sign. Okay. So obviously times, we have 6x squared minus 14x plus 4. And all over, let's say 3x minus 1. Now we've created quite a few brackets over here. That's good because at the end we're going to cancel these brackets out. Let's deal with this one over here, this advanced quad box, and let's see what we can do with this. So let's do this on this side over here. So two numbers are multiplied to get 6 times 4. Now I'm thinking about this and thinking, let's break this down even further. Let's say if we said to ourselves, we could divide everything by a common factor, which would be 2. We're going to half every single thing. There we go, 2. You should always try to factorize an advanced quad or anything for that matter. The answer will still be the same, okay? It'll make life much easier for you as well. So let's think of it, this should be in fact 3. Okay, so let's just deal with 3x squared minus 7x plus 2, okay? It'll give us the same answer if we were to take the whole thing in its entirety. So two numbers are multiplied to get 6 and add up to get minus 7. So let's think of two negatives because obviously the negative over here, so minus 6 and minus 1, minus 6 minus 1, that definitely works. Let's write the whole thing over here. So 3x squared, we'll write minus 6 first only because we can factorize this in the next step. Minus 1x or minus x, and this will be plus 2. Let's cut this in half. Okay, 3x over here, x minus 2. X minus 2, I'll write that in terms of writing it first, and we'll put minus 1 over here. So the final answer is going to be 3x minus 1 and x minus 2. So that is your final answer. We could put actually a 2 if you wanted to. In fact, we'll do that because that actually is the full answer, in fact, if you multiply the whole thing by 2 at the end. So the 2 over here is simply going to be the 2 from over here. 2 and 2, okay? It would be wrong if you did not include the 2 in this case because we're actually factorizing and not solving it. Okay, anyway, enough of that. So let's do the whole thing over here. Now let's write the whole thing again, and let's write this. So 5x plus 2 all over. Now look at this, x, this is dots, basic dots, x plus 2. I'll put a square bracket so you can see each step by step. X minus 2 over here. And this is times 2. I'm going to write what we put over there, 3x minus 1 and x minus 2. And this is all over 3x minus 1. Okay, now the fun bit, let's see what we can cancel out over here. So what brackets look the same? I think we're in a position to do this. So x plus 2, x plus 2. There you go, obviously. X minus 2 and x minus 2 as well. They go on either side of this. 3x minus 1 and 3x minus 1 go as well. So we're left with just this. We're left with basically, what are we left with? 5 times 2, because everything else has been cancelled out on the numerator. And the bottom one, this is just imaginary 1, x times 1, or just x. So 10 over x would be a final answer for all of that. That would be quite a tricky question, but it's quite doable actually, and that involves quite a lot of the techniques we've talked about, simple factorizing, hidden dots, and advanced quad box in this example over here.